Today we're going to set up and run simulations. An event is random if the outcome cannot be predicted beforehand. So for example, if we flip a coin, we don't know for certain if it will be heads or if it will be tails. Statisticians don't think of randomness as the annoying tendency of things to be unpredictable or haphazard. We think of it as a tool. If we were to look at numbers 1, 2, 3, 4, and I were to ask you to look them over and quickly pick a number at random, most people would choose number 3. 2 and 4 will usually come up as equal frequency, and very few pick 1, which is kind of weird, right? It's surprisingly difficult to generate random values even when they are equally likely. Computers have become a popular way to generate random numbers, even though they often do as much better as humans. Computers can't generate truly random numbers either. Since computers follow programs, the random numbers we get from computers are really pseudo-random, fake random. It's okay for our purposes. So we're going to look at an example, and we have a cereal box puts trading cards of athletes in their boxes to boost sales. 20% of these boxes have Tiger Woods, 30% of David Beckham, and the rest have Serena Williams. How many boxes do you expect to buy in order to get a complete set of cards? Well, it would be kind of silly for us to run to the supermarket and buy 40 boxes of Honey Nut Cheerios just to see if we obtain a complete set of cards. So we're going to imitate this so we can control it. And what we're really doing is we're simulating reality. If we look at our example, the first thing we're going to ask ourselves, what is it that we're doing over and over again? Well, we're identifying the component to be repeated. We're opening the cereal box and obtaining that trading card. Notice the second thing we're going to do is we're going to determine how to model the component's outcome. You can use 0 through 9 as your digits because our two percentages were provided here end in zeros. Now, you could also use 00 through 99. That is not wrong. Just remember, you have to be consistent. If you have single digits, all digits have to be single. If you're using double digits, all digits have to be double. Because on the AP exam, more than likely they're going to ask you to use a random number table and not the calculator to run your simulation. So 0 and 1 will represent a Tiger Woods card because 2 out of 10 digits is 20%. Then 2, 3, and 4 will represent a David Beckham card. 3 out of 10 is 30%, and the remaining digits will be Serena Williams. Now, did we have to start off with Tiger Woods? No, we could have switched the order in how we assigned our digits, which is fine, which is why when you do these, you have to tell me how you allocated them. The third thing we will do in this simulation is we're going to generate random digits to represent opening the boxes and continue until all trading cards are found. Now, I will actually do this with you on the next slide for step 4 and show you how to do this in your calculator. Fourth thing we're going to do is we're going to analyze the response variable. And the response variable here is the number of boxes until we get all 3. Okay, so when I run these, I like to do, it looks like a KWL chart. So we have our trial, we have our outcomes, and I like to put my response variable in that third column. So it looks like we're doing number of boxes until all 3 cards are found, or something like that. The next thing is it does not provide us a number table, so we're going to use our calculator. Remember from Unit 1, the problem with the calculator is if we don't all store our calculator to a specific value, then everyone's number generators will start at different places. So we are going to use 1119. And then you're going to look for the button that says stow. It's right above the on button. So in our calculator, we're going to type 1119, stow. Then we're going to push math. we're going to highlight PRB for probability, and we're going to choose option 1, rand. And then you'll probably have to hit enter, and maybe a second time. Now 1119 should show up in your home screen. The next step is we're going to push math again. We're going to highlight that probability. And this time we're going to select option 5, random integer. Now depending on which calculator you're using, you are either going to see random integer right away. If your stat wizards are on, you will see something else. So our smallest digit is 0, our largest digit is 9. And because we're not opening the same number of boxes every single time, we are going to close the parentheses. Now, if your calculator, when you do random integer, says lower, you're going to put a 0. If it says upper, you're going to put a 9. And if you see an N, we're going to leave that as 1. And then you'll hit enter on paste. Hopefully you get a 2. Well, a 2 falls into that 2, 3, 4 category, or David Beckham. And we're going to push enter again, and notice we get a 7. 7 falls into that Serena Williams category. And if we push enter again, we get a 1, which is our Tiger Woods. So because we have each category represented within our trial, we open 3 boxes. Let's do another one together. We get a 0, which is a Tiger, and then a 4, which is David Beckham, then a 0, which is Tiger, and then a 5, which is Serena Williams. So now we have each category represented from our digits that we've assigned. So this time we open 4 boxes. When you have all of your trials done, we'll talk about the next step. I'm going to pause the video and put the digits there.